Just to recap problem 5, since we got interrupted right in the middle, there was one decimal place, so that means the denominators were 10, which means the common denominator is 10. So we multiply each term, and there's 3 separate terms. This is considered one term, this is one, this is one. So we hit all the outside numbers. When we multiply by 10, that turns to 5. Multiply by 10, that turns to 11. And we said that that's an imaginary one when there's just a negative in front. So it's negative 1 times x plus 5. When we multiply that by 10, it turns into negative 10. Then we distributed and got 15x minus 10 less than. This turned into 11 minus 10x minus 50. So now we're ready we got rid of the fractions or decimals. We distributed. Now we're ready to combine like terms. And there's only one set of like terms, and they are right here, 11 and negative 50. So you should only have one x and one number on the left and one x and one constant on the right. So when I saw 3 terms, I knew I had like terms there. So the left side will stay the same. 15x minus 10 is less than. The right side's going to become negative 10x. So there's that. And then this is 11 minus 50, which would be negative 39. And you can verify that, especially if you miss signs a lot. 11 minus 50, negative 39. So when the signs are different, subtract and keep the sign of the larger. So now we're finally ready to start moving things. So we need all of our x's on the left. So we do the opposite because we're crossing the inequality symbol. So add 10x, add 10x, and we get 25x minus 10 is less than, this cancels, which was our purpose, negative 39. So then any constants we have need to be on the right side of the inequality. So we're crossing the inequality symbol. So again, we do the opposite. So then we get 25x. We haven't divided or multiplied by a negative anywhere. So notice the symbol's the same. It's still less than. Negative and a positive tells me to subtract and keep the sign of the larger. When the signs are different, subtract. 39 minus 10 is 29, but we keep the sign of the larger, negative. And then last step, this is times 25, so we do the opposite, and we're dividing by a positive 25, which does not change the symbol, remember. Only if you divide by a negative. So we still have the less than sign. And then if you want to go to your calculator to change that to a mixed number, you can. So negative 29 fraction bar, not division, 25. And that's negative 1 and 4/25. Again, if Alex asks for a fraction, you write that. If it asks for a mixed number, you write this. If it doesn't ask, then you can just write either one. So x is less than negative 1 and 4/25. Okay, so L is less than, which means shade left. We use a parenthesis because there's no equal sign. The left end of the number line is negative infinity, and this end point is negative 1 and 4/25. So then we drop the two numbers down in the same order, negative infinity first, and it always gets a parenthesis, and negative 1 and 4/25. And it gets a parenthesis because there's no equal in the original problem. Order matters, shape of your grouping symbols matter. So that is number 5. So I think we have 2 more to practice on the other page. So let's go ahead and begin. Let's get it up here. There we go. Focus. So now we have what's called a compound inequality. And the reason it's called that is because it has 3 sides. It has a left side, it has a middle, and it has a right side. Left side, middle, right side. Notice there's 2 inequalities. So our goal on this type of problem is to get what the variable inside alone. So I need to get that x alone. So I do the opposite, which would be add 1. So the only difference is, let me rewrite it just so it's a little bit bigger. So the only difference is now instead of adding it to 2 sides, I have to add 1 to all 3 sides. So to the middle, to the left, and to the right, because I can't upset that balance. So I have to do it to all 3 sides. But do you see why I'm doing it? Because I'm trying to do the opposite so I can get x alone. So now on the left side I have -1 less than. In the center I have x. Yay! Happy dance! My x is alone. Less than or equal to 3 plus 1, 4. So this is red. X is between -1 and 4, including 4. So x is between, because see how it's in the middle? So a lot of students go, I don't know how to graph that. Well, if you think of it as being in the middle, it's all the shading in between -1 and 4. So -1 is going to get a parenthesis, and 4 is going to get a bracket because of the equal sign. So I go to -1, I do a parenthesis. I go to +4, I do a bracket, and then I shade in between. So it's the easiest one of all because you don't have to think less than, greater than. You just think, oh, shade in between -1 and 4. So this is a parenthesis. It's a pretty crappy looking parenthesis, huh? This is a bracket, and we shade everything in between. So that's what my graph looks like. So let's go ahead and move this up here. -1 is less than x, which is less than or equal to 4. So x is everything in between -1 and 4, but including 4. So that's why we do the bracket. And the interval notation is so easy. This endpoint's -1, and it has a parenthesis. Then we put a comma. This endpoint is 4, and it has a bracket because of the equal sign. So although these look scary, they're the easiest ones of all, because you don't have to think, do I shade left? Do I shade right? You shade in between, because x is in the middle of or in between the 2 numbers. And then you just drop this down in the same order with the same grouping symbols. Cool, huh? So on 7, you have to get rid of the fraction. So multiply everything by 3. But again, I would stop the video right now and practice on this one all by yourself. So first multiply everything by 3 to get rid of the fraction, and then solve from there. And then turn the video back on and you can check it with my work. So we don't like fractions. So the first thing we want to do is get rid of that. So the LCD is 3. It's the only denominator. All the other denominators are 1. So I'm going to put a 3 here. I'm going to put a 3 here. I'm going to put a 3 here, and I'm going to put a 3 here. Because we learned in section 1.1 you can't skip any terms, and there's 4 terms. There's 1 on the left, 2 in the middle, 1 on the right. So I should have 3 written by all 4 terms. So what do we have here? Negative 63 is less than or equal to, and see how the 3's cancel? Or you could have said negative 6 divided by 3 and got negative 2, but it's just easier if you notice that they're the same. 3 divided by 3 is just 1, so they just cancel. So I'm left with negative 2x plus 27 is less than 21. So fraction free. Doesn't that look a lot easier than the original problem? Yeah, so just multiply every single thing by 3. So now remember what I said above. Our goal is to get x alone. So I need x all by itself in the center, just like we ended here. So first I need to move this, because remember we do division last. So addition and subtraction are done first when we're solving. So to move this out of the center, we have to do the opposite. But now since there are 3 sides, I have to do it to all 3 sides, to the left, to the middle, and to the right. So we have 10, carry our 1, so negative 90, less than or equal to, the whole reason we did the opposite is so that would cancel, and then we have negative 2x, and then less than, when the signs are different, we subtract. 27 minus 21 is 6, and keep the sign of the larger. So here's the tricky part. I wonder if you caught this. The last step is the opposite of multiplying by negative 2, which is dividing by negative 2. But what did we learn? Whenever you divide by a negative, you have to flip the symbol. So now you're probably going, oh, which one do I flip? You have to flip both of them. You don't get a pick. So I'm dividing by a negative, so that symbol's going to flip, and this one. So 2 negatives, positive 45. Flip the symbol, so now it's going to be greater than or equal to 2 negatives, positive 1x, which is just x. Flip the symbol, and your symbol should always be going the same direction. So if you ever get them going 2 different directions, that means you flipped one and forgot to flip the other. 2 negatives, positive 3. So now what the problem is we don't have our smallest number first. See how you're supposed to have your smallest number first, a less than sign, your x in the middle, your largest number second. So I have to flip this whole thing over and just make sure I keep all the symbols the way they are. So 3 is the smallest, and see how it's pointing to the 3? So when you flip it over, it should still be pointing to the 3. Your x stays in the center when you flip it, and then it's pointing to the x, and then 45. And this one's eating the 45, this one's eating. And remember how I said they should end up going the same direction? And if you have it from smallest to largest, they should both be less than signs, which they are. So you just completely tip it over, and 3 should be pointing to the 3, x stays in the center, then this is pointing to the x, open to the 45. So that is our final answer in the correct order. So 3 is less than x, less than or equal to 45. And remember, after this, it's an easy problem. All I have to do is put a parenthesis at 3, a bracket at 45, color in between. So we love it once we get to this step. So parenthesis at 3, because there's no equal sign, bracket at 45 because there is an equal sign, and X is in the middle, so that means shade everything in